Hello, friends. Welcome to the Awesome Algebro. Today's topic is going to be combining like terms. Now, combining like terms is one of the foundational concepts in algebra, so please make sure we pay very close attention. First, it might help if we know what a term is. Very easy concept. A term is just a mathematical expression that is separated by addition or subtraction signs. So if we see a problem like 3x plus 7y minus 2, we would look at that and notice that there are three separate parts. This would be considered three different terms. Now, those terms would be, and I'll highlight them. The first one would be 3x. We'll put that in orange. The next one would be positive 7y, and we'll put that in blue. And the last one, as you guessed it, would probably be negative 2, and we'll leave that in red. So those are three separate and distinct terms that are separated by the addition and subtraction signs. Now, I put them in different colors for a reason, so you could see that all of them are different from each other. We have an x, 3x, we have a y, positive 7y, and then we have a regular number, negative 2. All of them are different and distinct and cannot be combined because they are not exactly the same as each other. X's only want to combine with other X's, Y's only want to combine with other Y's, and regular numbers only would combine with other regular numbers. So when we think about combining like terms, what we want to do is put things together that are the same. All right, let's look at a problem. If we have negative 8a plus 10b minus 12a plus 3b, what we want to do is first identify what are our terms and then which ones are the same. And if they are the same, we can put those together. So if we look at this problem, we have four different terms. Our first term is negative 8a, and we'll put that in blue. Our next one would be positive 10b, and we'll put that in orange. Our next one is right next to it would be negative 12a, and we'll put that in blue because it matches with something else. And then we'll have our last one, positive 3b, and we'll put that in orange as well. What we want to do at this step is put things together that are the same. Do they match the ending variables? And in this case, we have negative 8a and negative 12a. Well, they both have an a at the end, so they are the same. They're part of the same group. We can combine them. So we'll look at the numbers. Negative 8 combined with negative 12 should give us negative 20. So we'll put negative 20a. Just like the next one, which we have in orange, now we have positive 10b combined with positive 3b. Well, if we look, positive 10 combined with positive 3 should give us positive 13. So we'll put positive 13b. The easiest way to think about combining like terms is maybe to think about it like last names. If we think about it in terms of people and their last names, who would you group together? So if we have, let's say, Mary Jones and we have a Chris Jones, well, we could assume they're part of the Jones family because they both have matching, identical last names. Mary Jones and Chris Jones are both part of the Jones family, so we could reasonably put them in that family tree somewhere along the line. Now, what if we had Mary Jones and we had Chris Ellis Jones? Now, even though we can both look and see that there's a Jones in both of their last names, we cannot absolutely assume that they're from the same family because their last names don't match identically. We need it to match precisely. So even though we see a Jones, and even though Ellis Jones has the same word, they're not exactly the same. It must match exactly. So we would not necessarily want to put those together, okay? So let's look at our example of last names that we have. The last names must match exactly. So in this situation, we have 6 people, and we'll start with our first person, P. Ellis. What we want to do is scan through the list and see, do we see anyone else from the Ellis family. Is there anyone else who has just the Ellis last name? And we look and we see Smith Ellis, but that's not exactly the same. And we see another one. So in this situation, we only have one person from the Ellis family. All right, let's go to the next person. Let's look at K. Smith. Okay, do we see anyone else with just the Smith last name? We see a Smith Ellis, and that doesn't match exactly. We see an N. Smith, Smith Ellis, no, and we see another B. Smith. Those three match exactly. And the last person is Smith Ellis, and that matches for that person, and it matches here as well. So the last names must match exactly. They can't be any deviation off. The same way last names must match here, we're going to apply that same concept to our variables. Variables must match exactly as well. So when we see something like a m and a m to the second power and an m to the fifth power, even though all of them do have the letter m, they don't match exactly. M's are not the same as m to the second power family. M to the second power family is not the same as M to the fifth family. They're all separate families because they all have separate last names. Even though they look similar, they're not exactly the same. Okay, let's take a look at an example and see if we can follow this concept. All right, here I have 6 different variables. Negative 9p, 5p to the second, 3p, 0.7p to the third, 4p to the third, and negative 2p to the second power. Now, what we want to do is simply match which ones have the exact same last name. Everything has to match exactly. All right, let's start off. All right, the first number we see is negative 9p. What we want to do is just look through the group and see, do we see any other variables that match p exactly? Not p to the second power, not p to the fifth power, not p to the 18th power. It has to be just p all by itself. And we look and we do see another. We see 3p right here. All right, our next one, let's look at 5p to the second. We just want to look and see, do we see any other p to the second powers anywhere? And we do. We see one right here at the end, negative 2p to the second. And last but not least, we see p to the third powers. We see 2. We see 0.7p to the third. And we also see 4p to the third. Okay. Now, there is an order that you want to write down your expression. You don't just write them down any way you want to. You want to write them in descending order of powers, meaning whatever the highest power, and then we just descend to the lowest power. In this situation, our highest power is the third. So we would go from the third power to the second power to the first power to no powers. Okay, let's see how that works in action. So we're going to look at the third powers first. We have 0.7 and 4. Those are both to the third powers. Let's combine 0.7 plus 4, 4.7, p to the third. Now, our next highest variable is to the second power, and we see one here, 5p to the second. Then we also see negative 2p to the second. Well, 5 combined with negative 2 should give us positive 3. Positive 3p to the second power. And last but not least, now we're going to do something to the first power, which is, in our case, negative 9p, 3p. Negative 9 combined with positive 3 should give us negative 6, negative 6p. Okay, let's take a look at a few more examples, and we're going to go a little bit faster this time around just to see if we can understand the concept quickly. All right, we're going to look at negative 7m plus 10 plus 6n plus 3m minus 1. So we'll take a look at our m's first. We'll scour and see, do we see any other m's? And we do. Positive 3m. Okay, let's look at our next one, which is our regular number, positive 10. Do we see any other regular numbers? And we do. We see negative 1. And last but not least, the one left over is positive 6n. We'll put that in a separate color as well. Now at this point, let's just put things together that match colors and match last variables. So in this case, let's put the m's together. Negative 7 combined with positive 3 should give us negative 4, negative 4m. Now we'll stick with the letters and put those first. And since nothing combines with positive 6n, we'll just write that down, positive 6n. And then let's put our regular numbers together. Positive 10 combined with negative 1 should give us positive 9. And with that one, we are done. Okay, next example. Now, this one looks intimidating, but it is not. Okay, this one looks long and intimidating. I promise you're going to get this right. Okay, our first is negative 2n to the third. Okay, we just need to look and see, do we see anything else that has an n to the third power? I look next. No, 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 no. So we're done with that one. All right, our next example will be positive 8n to the fifth. Do we see any other n to the fifth power? And we see one at the end. We see positive 4n to the fifth. And so we know we would combine those at the end. All right, last but not least, we see negative 7n to the second. Do we see any other n to the second powers? And we do right next to it, positive n to the second. Now, we do descending order of powers. So we want to start with the biggest exponent, which is n to the fifth. We have positive 8 combined with positive 4. That should give us positive 12, 12n to the fifth. All right, our next highest exponent, we don't have any n to the fourth, so we skip that one. Do we have any n to the thirds? All right, we do. We have negative 2n to the third. It didn't combine with anything, so we just write that down. Negative 2n to the third. And the last one, we have n to the second power. Negative 7n to the second plus n to the second. Now, please don't forget this step. There's a 1 in front of n squared. Okay, there's a number 1 in front. So when you combine those, negative 7 combined with positive 1, you should get negative 6n to the second. All right, our last example. All right, looks confusing, but you're going to get it just like that. You're going to get it so easily. Okay, our first one, AB. Do we see anything else that has an AB last name? Okay, I see one right in the middle, negative 4 AB. Okay, our next one, positive 8B. Do we see anything else that has a B last name? And we do. We see positive 5B. And last but not least, we see the negative A that is left over. Okay, let's combine them, and we color coded them so it'll be easy to match. All right, we'll start with our B's. Since B is a bigger letter than A, we'll start here. Positive 8 combined with positive 5 should give us positive 13, 13B. Okay, let's combine our ABs. Now, before you do, please don't forget, there's the number 1 that is hidden in front of AB. So it should be 1AB. So if you have 1 minus 4, 1 minus 4 should give you negative 3, negative 3AB. And last but not least, the one that's left over, negative A, we just bring that down because we didn't combine it with anything. All right, friends, we are done with combining like terms. I hope this helped you very much. Hey, friends, thanks for watching the Awesome Algebro. Please be sure to like, comment, share, and subscribe for the most awesome algebra tips available. And again, thank you for making me a part of your day.